My name is Sarah.
Hi, my name is Asma.
And today we'll be talking about
Periodicity.
Periodicity refers to the trends within the periodic table. This here is a periodic table. The periodic table is made up of elements that are positioned by their increasing atomic number. The atomic number is the sum of all the protons and neutrons in the nucleus. As you can see, the table starts from 1 and continues onward.
This is the element hydrogen. Hydrogen only has one proton in its nucleus. As such, its atomic number is 1. This is hydrogen's atomic structure. As shown in the picture, its nucleus only contains one proton. As such, it also contains one electron, which means it only has one outer shell. And this outer shell only contains one electron, as shown by the diagram. However, by changing the number of protons from in hydrogen to 2, we get the atom helium. And as such, by having 2 protons, it also needs another electron, which will be added to its outer shell. This then completes the first outer shell. Okay, this is helium. However, to change helium to lithium, we simply change the number of protons in the nucleus to 3. As such, we must then also balance out the protons with an extra electron. However, since the first outer shell is full, we must add another outer shell. In this outer shell, we can then put the one extra electron. We will now show you the trend for the next 8 elements going up to neon.
You're actually going to draw it out?
As shown, neon then fills up the second shell of it. As shown in the diagram, neon with 10 electrons fills up the second shell.
So now we will be talking about periodic trends, and the periodic trends we will be concentrating on are the atomic radii, the ionic radii, the first and second ionization energies, and electronegativity. And to do this, we will be using group 1, the alkali metals, and period 3 across from sodium to argon.
The atomic radius is half the distance from 2 adjacent bonded nuclei.
The atomic radius across a period from left to right will decrease. However, the atomic radius down a group will increase. As you go across a period, the number of protons increase as well as the number of electrons. However, the increase in number of electrons is on the same energy level. Therefore, the attraction between the electrons and protons increase, causing the atomic radius to increase. However, as you go down a group, the energy level increases. This causes the shielding effect to occur, which ultimately increases the atomic radius. Shielding effect is the repulsion of the outer valence electrons by the inner electrons from the protons in the nucleus. Therefore, down a group, the shielding effect increases, and so does the atomic radius.
Ionic radius. The ionic radius is the measure of an atom's ion in a crystal lattice. The ionic radius changes for negative and positive ions. Negative ions gain more electrons, meaning their attraction with the protons in the nucleus decreases, which causes the ionic radius to increase. However, cations lose electrons, meaning the electrons gain a stronger attraction with the protons in the nucleus, causing the radius to decrease.
Ionic radius decreases across a period, but increases down a group. Across a period, the attraction between the protons and the electrons increase. Because the electrons are held tightly by the protons, the ionic radius decreases. However, down a group, the elements are subjected to the shielding effect, causing the ionic radius to decrease.
Ionization energy. This is the amount of energy required to remove an electron from an atom in a gaseous state. As the attraction between the nucleus protons and the outside electrons increases, the ionization energy also increases.
Ionization energy increases across a period, but decreases down a group. Across a period, the electrons are held tighter by the protons, causing more energy to be required for the atom to lose an electron. However, down a group, due to the shielding effect, the proton does not have a tight grip on the electrons, making it easier for the atom to lose an electron, thereby decreasing the ionization energy. Furthermore, for an atom, its second ionization energy will be greater than its first. The reason is because once an atom loses an electron, the atom becomes a cation, aka a positively charged ion. And because there are more protons than electrons, the attraction between them is greater, causing it to be harder for the atom to lose a second electron.
Electronegativity. Electronegativity describes the tendency of an atom to attract electrons. This is dependent on the atomic and ionic radius of an atom.
Electronegativity increases across a period but decreases down a group. Across a period, the attraction between the protons and the electrons are greater, allowing the atom to be able to attract more electrons. However, down a group, the shielding effect weakens the attraction. So, in summary,